Example 2. I actually really like this example. It's actually pretty quick and easy. Hopefully you've noticed that all you got to do is condense and then drop. The natural log of 2t plus the natural log of 3t. When you have condensing with addition, you will multiply to do that. So what is 2t times 3t? Well, it's 6t squared. The natural log of 6t squared equals the natural log of 24. This is option 1. You get to drop the logarithms, and then you just have to solve. You could take that over and factor it. That's very fine. That's very possible. It's totally fine. But remember, you really need to factor when you have like x and x squared. Well, we don't have any x. We just have x squared or t squared. So you can actually set up to solve this one. You don't have to factor, even though you could if you wanted to. T squared equals 4. Force the square root, so t equals plus or minus 2. So let's check them. What's it going to be? If I check t is 2, you have, here's my check. The natural log of 2 times 2 is 4. The natural log of 3 times 2 is 6. And that is supposed to be the natural log of 24. When you condense these with multiplication, 4 times 6 is 24. So positive 2 works just fine. Now what about negative 2? When I plug in a negative, I start off with a problem right away. Good news is once you see it, you don't have to go any further. When I plug in a negative 2 in for t, I'm taking the logarithm of negative 4. That does not exist, making this guy extraneous. Can't do it. As soon as the first mistake happens, the first issue happens, you don't have to go forward. You don't have to keep going, which is nice. What you have to be comfortable with is knowing what it means to be extraneous. If it gives you a 0 or it gives you a negative, you're done. Okay. Example 3. Hopefully by now you're catching on. Condense and drop the logarithms. When I condense, I don't know why I just said t. I forgot what I was doing for a second. Log base 5. How do I put together t and t minus 4? Remember, you're multiplying whenever you condense through addition. So that is t squared minus 4t equals log base 5 of 21. So now that the logs are on each side, and there's just one log and one log, I can drop them. So what I really have to work with is t squared minus 4t equals 21. That is factorable, but of course to do that, I would have to notice that I need to subtract 21 to get 0 on one side, and then go from there. Factoring yet again never goes away. The good news is you're finally really good at it. You've been working really hard. You've come a long way this year. I'm really proud of you guys. So the factors of 21, negative 21 that give me negative 4, would be negative 7 and positive 3. We set those equal to 0 and solve. So t equals positive 7 and t equals negative 3. So now the question is, which one is going to work? Which one is not? Or, in an interesting twist, will they both work or will they both not? You won't know until you check them. So let's check the 7. Log base 5 of 7 plus log base 5 of 7 minus 4 is 3. That is supposed to equal log base 5 of 21. That's a 5. Do these condense back through multiplication to give you 21? Yeah, 7 times 3 is 21. 7 is a winner. Negative 3. Right off the bat, we plug in the negative 3 for t, and we already have a problem. You can't take the log of a negative number. Now, please be advised, that doesn't mean you can't have exponents that are negative. Whenever we're doing exponentials in the next lesson in 12.7, you will see that you can have negatives. It's not a big deal. Mostly because in exponential format, that's just sending it across the line, changing the sign. That's not a problem. It's the logarithms of negatives. That's what you can't do. It doesn't mean your answer can't be a negative either. That's the funny part. If this was a negative t. This one would be the extraneous one, because when I plug in the 7, I would have had log base 5 of negative 7. If I had plugged in the negative 3 right here, I would have minus negative 3, which turns it back to positive 3. So there are circumstances whenever the negative is not the issue. Again, you won't know until you actually put pencil to paper and try it. Okay, one that's a little bit different. We're going to condense both sides. We've got to condense the left side. We've got to condense the right side. When we condense both of these and they have subtraction, how do you condense when you're subtracting the logarithms? Subtraction condenses through division. And the one that you see first is the numerator. And the one that you see second that's being subtracted is the denominator. So we've got the natural log of y minus 3 over y minus 4 is equal to the natural log of y plus 3 over y. Well, now you can drop the logarithms. Y minus 3 over y minus 4 equals y plus 3 over y. In Unit 11, we just finished solving these. You could cross multiply. You could make the denominators the same and drop the denominator. You got options. So what's crazy is I've told you all year long, math builds. Yet again, case in point, it's still building. We just finished how to solve when you have a variable in the denominator. So what do you want to do? If you cross multiply, you've got y times y minus 3. So y squared minus 3y. And that will be equal to, when you cross multiply the other diagonal, you'll have y minus 4 times y plus 3, which is y squared minus 1y, because the o and the I in FOIL give me negative 1, minus 12, which would be the L in FOIL. So the first, the outer, the inner, and the last. If you had decided to figure out that the LCD was y times y minus 4, you would have given that y, and you would have done the same to the numerator, keep it balanced. You still would have ended up right back here. And this one you would have given y minus 4 and y minus 4, and you would have ended up right back here. So it doesn't matter if you cross multiply or give it the LCD whenever it's two ratios that equal to each other. It's going to be the same thing. So let's finish it out. I need to get my y squareds together. It looks like, because I've got y squared and y, it looks like that I'm going to start to FOIL, or factor, excuse me. So I need to start getting things together. Now what ends up happening on this one is that as soon as you start moving things around, oh look at that, y squared's gone. So I need some more space, so I'm going to go up here. So we've got negative 3y equals negative y minus 12. Well, I don't have to factor anymore. I can SADMAP because I just lost my y squared. And that ends up being negative 2y equals negative 12. So y equals positive 6. I only got one answer. That's fine. There's not a big deal with that. So let's see if it's true. When I check it, the natural log, y minus 3, so 6 minus 3 is 3, minus the natural log of 6 minus 4 is 2. That is supposed to equal the natural log of 6 plus 3 is 9, minus the natural log of 3. I'm sorry, it's 6. I'm checking. Of 6. When these come together, that is the natural log of 3 divided by 2, so 1.5. When these come together, when we condense through division, that is the natural log of 9 over 6. Isn't 9 over 6 the same as 3 over 2? It checks out. Totally works. I'm clipping along pretty fast because I don't want this to take forever, but you need to see how weird these things get. They're not terrible, but some of them are a little more challenging than others. The more you do, the better you'll get, and the faster you'll get. So hopefully you're keeping up just fine. Okay, so here's going to be finally an option 2. In the beginning of this document, I don't know if I still have it up there or not. No, I don't. Okay. I had option 1 and option 2. Option 1 being logarithms on both sides, you get to drop. Option 2 being you only have logarithms on one side, you'll condense and you'll loop swoop. You'll change it to exponential to solve it. This is that problem. So if we condense the logarithms and we have addition, we'll be condensing them through multiplication. So I've got 3x times x, 3x squared, and 3x times negative 4, negative 12x. That equals 2. So what now? Well, now that we have one logarithm and we're doing the second option of how to solve logs, not the first, because you can't drop the logarithms when they're not both on each side, your only option is to loop swoop, to change it from bay to bia. So the base to the exponent equals the answer. So 6 to the second equals 3x squared minus 12x. Awesome, easy. So that would be 36. I then need to subtract 36. So I can now factor out a 3, leaving x squared minus 4x minus 12. I can then factor that further. I took out a GCF, but the factors of negative 12 that give me negative 4 would be negative 6 and positive 2. Set everything equal to 0. When I set 3 equal to 0, there's no x, there's no answer. So remember what this is really is mathematically that would be a stretch by 3, vertical stretch by 3. The next one, set x minus 6 equal to 0. That would be if it were quadratic. I might be talking out of turn, so I apologize. X plus 2 equals 0, so x equals negative 2. And now we check for extraneous to see if one works and one doesn't. When I plug in the 6 times 3 is 18, so we have log base 6 of 18. We have log base 6 of 6 minus 4 is 2, and that's supposed to be the answer 2. Here we go. When you condense these, you have log base 6 of, well, 18 times 2 is 36. Is 6 to the second equal to 36 when you convert it to exponential form? Yeah, totally is. Positive 6 totally checks out. Now, let's try negative 2. Hopefully you're catching on really fast and that it's automatically out. Not because it's negative, but because it would make negative 6 right there. Just to start off with, you would have a problem. You'd have an issue. So it's out.